I'm really looking forward to this session. Carbon and carbon accounting as relates to mass timber is a constantly evolving topic and one that I find generates a lot of interest and a lot of questions. And here to help us answer that, some of those might be is Caitlin Clark, who is Senior Fellow in Supply Chains at the Nature Conservancy. She came all the way from DC, and so please help me welcome her.
Thank you. Hi, everyone. Thank you very much for the introduction. My name is Caitlin Clark. I am a Senior Fellow for Supply Chains at the Nature Conservancy. I'm based at our worldwide office in Washington, DC. My work focuses on supply chain and landscape solutions that are related to forests and forest products. So I am not a carbon accounting expert, so I will not be doing a deep dive into methodologies today, but hopefully just laying out a useful framework. But I'm always thrilled to be here on the West Coast, and so I'd really like to thank Skip and the Forterra team for having me here today. So I was asked to speak about carbon concepts and tools. Most of us in the room, I think, believe, based on what I agree is great evidence, that mass timber as a construction material can be really good for the environment. At TNC, we think it can deliver a lot of important benefits. So I'm going to start with a very brief overview, I promise, of who we are at the Nature Conservancy and why we care about this issue and how it fits into our overall strategies. And then I'll talk about how we see mass timber relating to the work that we do on climate and forestry. I'll outline the framework that we use to relate buildings to forests and to forest management, discuss what our general sort of holy grail is in terms of how we can understand the impact of mass timber, and then talk a little bit about how some of the tools that exist can help us do that. So very briefly, the Nature Conservancy is the largest conservation organization in the world. We have nearly 4,000 staff with chapter offices in every state in the United States and in 76 countries. So our mission is to conserve the lands and waters on which all life depends. We take a science-based approach to that mission, and we work very closely with a huge range of partners, including many of you in the room. Here in Washington, we have colleagues all over the state working on science, policy, and practice on issues ranging from fire management in the Central Cascades to coastal resilience in Puget Sound. But all of us, sure, sorry, let's try that. It's probably me. Is that better? Yeah. Okay, great. I'll try and pull that over. Okay, can you hear me? Yes. Great, thank you. So all of us at TNC are aligned with what we call the shared conservation agenda, which underpins our work in every state and country and at every level of the organization. And so this has 4 pillars. They are protecting land and water, providing food and water sustainably, building healthy cities, and the one that is most in the news these days, which is tackling climate change. So I'm just going to take a minute here to reiterate the scope and scale of the climate emergency that we are all facing. We have until 2030, which is 10 years away, to get the planet's emissions under control in order to meet, we hope, the 2 degrees Celsius warming target that the IPCC has assessed would help us avoid the very worst impacts of climate change. That 2-degree target represents a massive shift in the way that all of us live and work, and we have 10 years, which is not a lot of time. So I'm not saying this to lecture anybody because I know everyone in the room is well aware of the fact that we face a climate crisis. My point is to underscore the absolute urgency with which all of us are called to help solve this problem in whatever way we can. So let's step back for a moment and think big. Let's, for the sake of argument, assume that climate change is the most significant challenge facing human civilization, and let's assume that we know it's caused by too much carbon dioxide. So we need some innovative technology that can suck this carbon dioxide out of the atmosphere and store it away. It needs to be fast, cheap, self-replicating. It'd be really great if it's gone through rigorous prototyping, like maybe 3.5 billion years of it. Oh, it exists. It's a tree. They are widely available. They've been testing themselves out over billions of years of evolution. They're really good at what they do. They're cheap, and they can reproduce themselves, which is awesome. And they give us all of this other great stuff like clean air and biodiversity, clean water and healthy soil for free. And they also provide all kinds of other useful products like fuel and fiber. So we love trees. And we know that trees and forests are lots of things besides climate answers. But we also know that they're really important parts of the climate solution. But when we tried to find out how much of that solution they were, we realized there weren't really very good numbers available. So in 2017, we released a paper called Natural Climate Solutions. And that paper built on the work of dozens of scientists at TNC, as well as a lot of our partner institutions. So that's the foundational science document for much of the work that we do, and for the work of TNC's Global Forestry and Wood Products team. And we are doing continuous work to sort of improve and refine this document and to apply it to different landscapes and regions and different pathways. So what are natural climate solutions? Broadly speaking, there are a series of ways that we can put nature to work as a carbon sink. They work across forests, grasslands and agricultural lands, and wetlands. And they basically involve three broad categories of actions. Protect from loss or conversion, manage working lands appropriately to conserve and improve their ability to store carbon both above and below ground, and restore native cover whenever possible. NCS strategies together can help us bend the curve of global carbon emissions. So this slide shows the business as usual pathway. This is actually a few years old, but that's continued up through 2020. And this is going to lead us to climate disaster if we're not careful. The 2-degree path, as you can see, is a pretty steep decline in emissions, and it represents major changes to decarbonize the global economy. And that's not going to be easy or cheap. And it's not happening at the speed and scale that we need it to. Natural climate solutions can help us get to that 2-degree pathway a little bit faster and hopefully a little bit less painfully. It's really important to note here that these are not a substitute for decarbonizing, and they don't buy us time. We can't plant trees instead of addressing transportation emissions. We have to do both. So these are just a necessary part of the solution. And as with all climate mitigating strategies, the faster we implement them, the better. Both because it gets us off that business as usual pathway faster, and because potential climate feedback loops mean that some of them might not work as well if we wait. And the situation is pretty urgent. So how much can natural climate solutions deliver? According to our research, we think we can get more than 1/3 of the needed emissions reductions, although it's important to note that this is the biophysical maximum and not a full accounting of the policies and enabling conditions that might allow these to actually work in a given place. So the main thrust of the NCS paper is this chart, and it shows the mitigation potential for various methods, and we call these pathways. There's a lot going on in this paper, but the main takeaways for our purposes today are the following. One is that nature could get us a lot of the way to where we need to be. And two is that nature can do a lot, but forests have to do most of it. You can see that most of these high impact pathways are under the forest category. So take a look at the top bar. That represents the possible greenhouse gas benefits that we could get from reforestation. So we think this is really exciting. The opportunity there is huge. But 100% delivery of that amount of reforestation represents more than 500 million acres of new forests by 2030. Should represent the largest land use change in human history. So to put that in perspective, to get to 500 million acres, you'd have to add up the entire land masses of British Columbia, Washington, Oregon, and California, and you'd still be missing an area the size of North Dakota. To further illustrate this challenge, the amount of land we're talking about is 5 to 15 times the amount that the world reforests on its own every decade. So we need to massively scale up because small changes are not going to move the needle on climate. So to illustrate why we think wood products markets really matter in this effort, here's a look at a few sources of revenue that affect forests. You can see the sort of sad forest carbon markets, which have never really taken off, the entire budget of the US Forest Service, and US charitable giving to the environment. And that's not on climate issues, that's total environment-related giving. And all of this is completely dwarfed by the scale of the wood products market. So that scale offers some clues about how to accomplish this, because ways to drive change at this scale are pretty limited. And here's a really brief overview of global forest extent in the past quarter century or so. Forest area is actually increasing in many places, mostly outside of the tropics and subtropics. We've added about 110 million hectares to global forest cover since 1990. And that's a lot, but it's only about half of what we need to add again in order to reach our mitigation target. It's mostly been driven by markets, so it has not been driven by government initiatives to reforest. But over the same period, global demand for wood has been pretty stagnant. So you can see world population has increased by 50%, GDP has doubled, wood use has increased about 10%. So we're not really running out of wood, but we need more forests. So how can we increase that supply? We have two key premises here. One is that previously forested land, which is not currently regenerating forest, is being used for something else. And the second is that catalyzing reforestation is therefore primarily an issue of catalyzing incentives for landowners. So we want forests to be the most attractive land use available to a landowner or a decision maker, more attractive than cropping or pasture, and more attractive than sort of the far end of suburban development. So we're also facing a basic economic problem of supply and demand where there's arguably too much wood available on the market. And it's hard to make a good financial argument that people who are already managing trees ought to be planting more of them. So we looked at the market on the other end of the supply-demand equation. So we did an extensive analysis of the best case opportunities for what kinds of timber products might be useful in this situation. Which ones would be likely to drive demand, and which ones would be likely to drive the right kinds of demand that would have other useful environmental and preferably social benefits. So the market is really big, it's very diverse. We didn't go into this analysis with any preconceptions about what the best sorts of products might be. But we did end up concluding that mass timber for construction is the best way to stimulate the market for wood products for a wide variety of reasons. It's a long-lived product, stores carbon for a long time, substitutes for some other materials that are a lot harder on the environment, and there are a lot of really exciting co-benefits. So I'm talking about mass timber it's a shorthand for lots of different structural components made from engineered wood. I don't want to spend too much time on the non-carbon benefits of mass timber because I'm pretty sure everybody here already knows about them. But we do think that mass timber construction can make our cities safer by reducing construction impacts. It's beautiful, people like being around it. And we also think it's pretty exciting that as a construction material, it can help revitalize some of the forest-dependent rural economies that could really use the help. And in that way, it's a really neat way to share some of the economic benefits that cities have seen in the past 10 years with rural economies. But we also have to note the reality of what we're facing in emissions terms. The updated scientific consensus is that we have to keep warming to 1.5 degrees Celsius. So that means that this year, 2020, has to be the peak. This is the most emissions we can ever have this year. And by 2030, they need to be half of what they are now, and we all need to be at net zero by 2050. That's hugely ambitious, especially considering that we have a growing global population that is urbanizing. So because buildings are responsible for about 40% of global emissions, and global floor area is meant to double in the next 40 years, if we're going to achieve that without completely destroying the planet, we need a new approach. And we think that mass timber is a key component of what that strategy could look like. So from a carbon perspective, what we really like about mass timber as a material is that it allows you to stack up the carbon benefits. At TNC, we call this the 3S framework. And it's that framework that I'd like to go into in more detail before I talk through some of the tools for assessing building impacts on the environment. I think it provides a nice way to think about the various issues and impacts that mass timber and forestry have. So what we're looking at here is how to figure out the impact that mass timber is having on the climate. In other words, what does the atmosphere see differently as a result of this building method? And how can we affect that with the choices that we make about building materials and forest management? And how can we use the existing tools that have been and are being developed to answer these questions and to make optimal choices for the right situation? So the 3 S's stand for sequestration, storage, and substitution. It doesn't roll off the tongue, but that's what they are. Sequestration refers to the carbon that trees are storing in their tissues as they grow. Storage refers to locking that carbon away in a product like CLT. And substitution is what we get by using those products instead of materials that we know are harder on the environment, like concrete and steel. So when you stack those up, as mass timber allows us to do, we think you can get a pretty exciting suite of climate benefits. You can also see this minus sign representing production and residues. So that's important because it discounts the benefits based on the impacts caused by the production and manufacturing process of the mass timber material itself. We'll come back to that. So each of these 3 S's encompasses a wide variety of choices and options. And we think that it can help us clean up a little bit some of the thinking around mass timber building impact, which can be difficult to tease apart, and imagine some good areas for future work. So let's talk through some of the things that can make each of the S's bigger or smaller. Can you still hear me? Okay. So substitution is one of the more straightforward pieces to look at, because here is where we're comparing mass timber directly with other building materials. And the key question here is, what does the atmosphere see differently in terms of emissions when mass timber is used instead of something else? In other words, what's the displacement effect? So under the substitution category, you compare the emissions associated with the production of raw materials, processing, and transportation to building sites, along with a few other things. These can actually be pretty easily calculated. So for mass timber products, you're thinking, of course, about the wood itself, but also things like the resins and glues used to make the panels or the structural beams and what their impacts are, about manufacturing, the facilities that make CLT and mass timber and what their energy use looks like, thinking about transportation impacts, where did that timber come from, how did it get to the manufacturing facility, how far away is that facility from your assembly site, what vehicles were used in the transportation and what fuel did those vehicles use, and what does that profile look like? Then there are also substitution category impacts associated with how we obtain the raw material, and these are also pretty straightforward to calculate and incorporate. And that includes some of the nuts and bolts of forestry management. So the impacts associated with obtaining seedlings and fertilizer, manufacturing fertilizer, planting those seedlings, maintenance, equipment emissions from harvesting and thinning, and that sort of thing. So these issues are all well encapsulated by EPDs, or environmental product declarations, and they calculate the environmental profile of products. In most manufactured products, there are pretty precise EPDs available for specific products and manufacturing processes. But for forest products, we usually have generic EPDs for a product category. That's not always true, but it's mostly true. So there is a gap between the more exact measurements available for conventional materials and the more generic ones available for forest products, but they're still really useful as a basis of comparison between material types. So one tool that's really great for looking at this is the Embodied Carbon and Construction Calculator developed by the Carbon Leadership Forum, which allows you to compare EPDs, and it's a really good way to look at these substitution benefits, because you can see normalized numbers that let you compare across product categories in new ways so you can make the best possible decisions about what kinds of products to include. So we think EPDs and the E3 tool are really important in this substitution scope. And when you think about the broader substitution benefits, you also need to think about the operational impact of those material choices. So it's not just embodied carbon in the structure itself, but the ways that that material is going to make that building perform over its lifespan. So how the building is heated and cooled, for example, and whether mass timber has an impact on that and what that impact is. And these are questions that get folded into the life cycle analysis, or the LCA. And that can be done at different scopes. You can look at component products or the building as a whole to look at its total impact. And another thing that's harder to quantify, but is a real substitution benefit, is the effect of the exposed timber on tenants and users. People like being around wood. It makes us happier and calmer and more productive. Does that have an environmental impact? I would argue that it probably does. So when we get to the second S, or storage, things start to get a little bit more complicated. And this is primarily related to the impermanence of storage as a concept. So it's pretty easy to calculate how much carbon is stored in wood products. It's also pretty easy to calculate carbon storage in other materials. But the thing that makes storage difficult is that it's a temporary benefit. So essentially, when you manufacture a CLT panel, you've taken carbon out of the atmosphere by locking it into a product, and then you're using that product to do something. But the carbon hasn't gone away. It's just locked up for some amount of time. So we don't really know yet how to best combine this with the permanent benefits of carbon impact. So do we just add it up? Do we use some kind of discount rate that's based on the expected lifespan of the building? There isn't a general agreement on this, and we don't want to either over or undervalue the storage benefits, because carbon that sits in building materials could do that for a long time. Cities full of mass timber could conceivably store millions of tons of carbon in a pretty stable way, but it's not a completely permanent one, and we don't really know what the ultimate fate of those buildings will be. So other materials might also have carbon footprints that change over time. There are some concretes that can absorb some amount of carbon dioxide, for example. And so it's not necessarily a static issue. But the permanence issue does mean that this will always be, in some ways, a conditional benefit. One way to help ensure that it's as big a benefit as possible is to pay really close attention to the building's design stage and its end-of-life plans. So is the timber going to stay dry? Because when it rots, it will be emitting carbon. Can it be removed? What happens to the material when the building isn't being used anymore? Can it be disassembled? Can the component pieces be reused, or does it have to be demolished? So is that timber ultimately going to end up in a landfill, or can it sort of be taken out of the carbon economy permanently? So the storage can be, in effect, indefinite if attention is paid very closely at the beginning to the composition and design of the building. So whole building life cycle analysis is a tool that can help a lot with this because it does force you to think through building end-of-life issues in a very specific way. So the third and final S, sequestration, is in a lot of ways the most complicated. So we're talking about carbon stored by trees in their tissues, like wood, but also leaves and twigs as they grow. So the amount of carbon that a forest can store depends very strongly on the scale over area and time, as well as lots of other questions like how fast the trees are growing in that particular region, and how the forest is being managed. Sequestration is heavily influenced by forest management practices. Managed commercial forests that are well managed as a unit basically have unchanged carbon stock over time. Harvesting a stand creates a negative impact, but then it grows back. So it basically returns the carbon stock more or less to its original state. In the US, for a variety of reasons, we know that forest cover is stable and forest stock is increasing, and that's been the case for decades. So at a high level, we know that those things are true, but it doesn't really tell us anything specific about a particular place or a particular project. And one more source of complication with the sequestration benefit is that impacts on forests vary as a result of changes in demand. So you could see a landowner taking advantage of market spikes to convert land to other uses. So in that case, you might see deforestation on the margins as people respond to signals like very high agricultural prices or an expanding metro area frontier. They want to sell their land to developers. You could also, which of course we're trying to incentivize with all of this, see landowners planting trees in order to meet the demand for mass timber materials. You could also see people changing rotation lengths in response to various market signals. Increased rotation lengths generally improve carbon stocks. So changes here are highly variable and they make a big difference. So how do these things stack up? So to illustrate this, we can look at the results of a very simple analysis that we did on an ideal area of pine forest. This is loblolly pine plantation in the southeast US. It's a 10-hectare plot. And these are the mass timber benefits. So this is what you would get if you were managing these 10 hectares for mass timber production over 150 years. So the x-axis is time, and the y-axis is tons of carbon dioxide equivalent removed from the atmosphere per year. So you can see how nicely this all stacks up. So it's an intensively managed pine plantation, has a high growth rate. So that builds up a carbon stock on the landscape, which is dark green. It can also store significant additional carbon in the products themselves. So that storage benefit is represented by the lighter green. And that's carbon locked up in the mass timber buildings that you're making with the products from that forest. You also get a substantial benefit from avoided emissions because cement and steel have such a high impact. So the red line represents a discount. So that's the net balance once you account for process emissions. And the yellow dotted line is the natural regeneration baseline for forest carbon. So that's what you would get if you left this 10 hectares alone and waited for it to grow some trees, which it will. But you can see that the area under the curve when you're managing it for mass timber is substantially bigger than it is if you just let this plot regenerate naturally. So in this case, you can get a lot of climate benefit from managing this area for mass timber. But that's not always the case. So here's the same 10 hectares, and we've done some modeling where the fiber is being used for packaging to replace plastic. So what you see here are shorter rotations. They're producing less landscape carbon stock. There's a very minimal storage benefit because packaging isn't durable, so that carbon basically escapes back into the atmosphere almost immediately. So that whole part of the chart has basically disappeared. And you have less of a substitution benefit because plastic packaging for concrete is less carbon intensive than the production of concrete and steel, largely speaking. You also have higher process emissions. That's represented by a bigger discount on the red line. And so when you look at the regeneration baseline, you can see that from a carbon standpoint, there might not be a great argument in this case for managing this forest for pulp and paper versus letting it regenerate naturally. So this is one potential outcome of a different management and substitution regime and a different use of the forest product. So, crucially, both of these slides are assuming that the material is coming off of a sustainably managed forest. So what happens when that's not the case? When the forest isn't doing well, or in this case is being cleared and left deforested, this is a mass timber from deforestation scenario, because we were interested in looking at what would happen if you weren't taking this off of a managed area. So you can see that when the land use is changing and the forest is disappearing, the substitution and storage benefits are not compensating for the loss of that forest. So we need to make sure that sustainable management is at the center of our work. And this is also important because it shows how crucial it is that life cycle assessments of forest products accurately convey the land management regime that they come from. Without that, the storage and substitution benefits of the product may well be real, but the atmosphere isn't seeing any benefit. In fact, in this case, it's seeing more emissions. So this is really, really important. So the question that we ultimately want to be able to answer from a policy perspective, and that means both for policymakers at a broader scale and for architects and developers at the project scale, is this. What is the impact of a marginal change in demand for mass timber products on the total system? And by that we mean forest carbon stocks, we mean storage and substitution and process emissions. What we'd really love to be able to say is that one more CLT panel's worth of demand in Seattle has X amount of impact on forest carbon stocks in Washington state. And we'll never be able to get there because the system is much too complex for that. But that's the kind of question that we're trying to get at. So if we see significant shifts in demand, what does that mean on the ground? We could imagine carbon stocks declining in some places as rotations increase, but storage and substitution might increase because you're putting that timber in buildings. And that might or might not offset declines in sequestration. Could also see policies that mean to increase forest carbon stock might reduce storage and substitution by disincentivizing forest product use. Or we could see, and this would be ideal, policies where all of these things are moving in tandem to the benefit of the broader environment. So we'd be able to line up what's best for carbon stocks in managed forests with maximum storage and substitution benefits. So figuring out the answers to these questions is complicated by the fact that carbon accounting for forest carbon and product carbon accounting are completely separate fields. So stocks of forest carbon, broadly speaking, are just reported separately from industrial emissions. That makes sense for a lot of reasons, but it does mean that the separation between highly interrelated parts of this system is reflected in increased confusion about how to calculate the overall impact. Or maybe not confusion, just difficulty. So in terms of the 3S framework, basically what I'm saying is that sequestration is separated from storage and substitution, and that's reflected in the approaches to building impact. So we can walk through just a few tools that are available for looking at building impacts on the environment. There are a lot. This is an area of research and development that is seeing some really exciting innovations. So earlier I mentioned environmental product declarations and life cycle analysis. So go into that in slightly more detail, keeping in mind that at least half of this room knows a hell of a lot more about building LCAs than I do. So the Carbon Leadership Forum has produced a huge variety of incredibly useful tools. They include not just the EC3 tool that lets you compare all kinds of useful EPD information about different products, but lots of maybe less sort of fizzy, but very useful insights and guidance about how to conduct LCAs. So in addition to the LCA practice guide, which is published by the Carbon Leadership Forum, there are really great reports from the Athena Sustainable Materials Institute, Architecture 2030, as well as Woodworks, and a lot of other organizations. And these are really good for learning more about life cycle analysis and what's in scope and what's not in scope. And they're really helpful, and they're also fun to play with. And then there are some really useful tools like Tally, Revit, that are aimed at taking some of the pain out of the comparison process and making it easier to make environmentally friendly material choices. So these are really great tools. They have a lot of incredibly impressive work behind them. They've really advanced the field, and you can now tell a lot of things about the amount of carbon in your materials and the benefit you can get versus other material choices. The challenge from our perspective is this, with a caveat that this slide is hugely oversimplified. So there's very little debate on the substitution benefit. It's difficult to calculate, but it is calculable. And we can figure out what that looks like. We need better agreement on how to account for the storage benefit, but that's doable. We just need to think through building lifespan and end-of-life issues. But when it comes to sequestration, we need a much better sense of how to account for that benefit and its impact on forests and how to connect these things. So most of the tools that are available don't address specific land use and land use change. And that's not a knock on any particular tool. It's just that life cycle analysis was not designed for this purpose. I've mostly used it in the agricultural sector, and it's the same deal there. Like, land use change is left out entirely, and it's huge. So we know that the quality of forest management and where those trees come from is a huge piece of the overall puzzle, such that without it, you're really missing a lot of what you need in order to understand the whole picture. So we're helping to coordinate a large global modeling study that we hope can help address some of these issues. It's basically ratcheting life cycle analysis down into specific regions with some economic modeling as well, so that we can understand demand pattern impact and hopefully have a better sense of land use impacts and the local safeguards that are necessary in various places. Here's a list of our collaborators on that project. I think some of you are in the room today, so I hope I'll get a chance to meet you in person. And we're expecting some initial results from this initiative in March. We're really hoping that these studies can help us bridge that sequestration gap so that we can feed high quality information about forest and land use impacts into current models. So there are two big reasons from our perspective that we need to be able to do that. First of all, is that until we can, we might be over or underestimating the effects of mass timber construction on the climate. When long-lived forest products markets can drive forest regeneration and restoration, that's great. When they drive sustainable forest management, that's great. If they are somehow to drive deforestation, the storage and substitution benefits cannot overcome that damage. So forest health and sustainable forest management practices have to be the underlying principle here, or else nothing will work the way that we all want it to. Second, the number one question that we get when we talk about ways that we could use forest products markets to drive climate action is, well, what does this mean for forests? Aren't you just talking about deforestation? And partly this is because the general public is not necessarily well informed about what forest management looks like. But partly this is because we don't have great information for them. And unless and until we have a good framework and an analysis tool that policymakers and the public can rely on, it's hard to imagine that forest products can be a widely trusted carbon mitigation tool. And we think, as I've said, that they really need to be. That trust and credibility matters a lot because general trust in the forest products industry and the sector at large is pretty low, even though most people recognize that wood is an environmentally friendly material. So there's a big gap here, which we refer to at TNC as the social license gap. And that really underscores the need to have solid, credible tools that people feel are trustworthy and reliable, and that really relate materials to the forest. So all of this takes me back to the earlier question about what a panel of CLT in Seattle could mean on the ground somewhere else in Washington. And that is an unreasonable and unrealistic question. A model that allowed us to see the impact of a change that small on the forest would be impossible. But we don't know that we need to get 100% of the way there. Maybe we could just get 60 or 80% of the way there. We do think it's likely that as a community, we can probably come to an agreement on some simple rules that get us most of the way. So one thought is that if there were a policy, so you could imagine a city government wanting to prioritize this construction material. You could imagine a corporation maybe wanting to build a new headquarters out of mass timber as part of their climate targets. So if they're trying to incentivize the use of mass timber in buildings, we could imagine the creation of a fairly simple test to apply to it. You could access that incentive by, for example, sourcing sustainable timber from forests that you know are being responsibly managed for future generations. And we think that addresses the sequestration benefit pretty well. At a regional level, so let's say maybe the level of the Forest Service region, we could imagine a very simple wood basket rule. Like, for example, that rule has to have a stable forest area and stable or increasing forest stock. And that could provide, we think, reasonable confidence that the market is not destabilizing the wood basin. So maybe that could be part of the way to incentivize this movement while helping to guard against unintended consequences. So My question for you all is whether that is a useful way forward. And finally, I'd like to thank you all for being here and for listening to me talk for quite some time. So if you have questions, I think we have a couple of minutes. So I am happy to attempt to answer them to the best of my ability. Thank you.
Any states or anywhere in the world where they might have, at a policy level, there's been some incentives that have been put in place based on use of wood products or measured by carbon intensity relative to concrete and steel?
I don't. Does anyone else? Because it's completely possible that that exists.
In Europe, there's a carbon accounting system. We've had Andrew Law, an architect from London, out and talked about a lot of incentives for the.
That's great. Yeah, I would have guessed somewhere in Europe, but it would only have been a guess. So thank you.
And the requirement of PVs for on-site power generation. If you couldn't do that because you all living with a small site, you would take carbon offsets with carbon instead of opting for power generation on-site. Or the UK model, I think.
Interesting.
I'm Mary O'Neill, and I'm with Quorum. We do the life cycle assessment.
Yes.
I'm actually a little surprised that there's such a lack of clarity around that sequestration component, because that's actually included in environmental product declarations, not built into the cubic meter, because that's not how you measure that, but certainly in the reporting of it. So it seems to me that, at least in the environmental product declarations that are coming out now, and that will be out when they go through review, there should be a lot more clarity.
That's great.
To me, it's like, yeah, we've addressed that, we've been asked to address that. The new product category rule says you must identify, sustainable, non-sustainable, stable, concrete. And so I think that there can be a lot more clarity in the new environmental product declarations. And then the other thing that I think is kind of interesting and needs to be unpacked a little bit, we're working very closely with EC3 because the way that wood is currently put into that model actually penalizes it because it's a general estimate. A general estimate actually represents the weighted allocation of where you would get wood.
Right. There's
only 5 facilities in North America. They might get their wood from anywhere, not necessarily from a specific wood basket. So there are, I think, some unpacking that needs to be done there, some clarification, but I don't actually think that it's necessarily included that it's the.
That's great. I would be very happy for that to be the case.
Just a comment or question on your social license gap. Is TNC willing to help narrow that gap? I mean, for a lot of us, the idea of talking about sustainable forestry practices, I think the only place you wouldn't see that in the state of Washington would be if the land purchase specifically to be, create a subdivision or apartments or whatever. Anywhere else, at least from where my perspective, I don't see that there is. Everything is sustainable from our, some of the most stringent forest practice rules in the country or in the world. Forest and Fish Act, 25 years now, 20 years now since we passed that. Is there more being done? I mean, I'm not going to say that our friends in the concrete and steel industry are actually out there lobbying to widen that gap. I'm not going to say that, but I think they are. Timber needs help.
Yeah, I mean, let me be clear about that slide. That's not TNC's views. Those are from the North American Forest Partnership Survey that was done, I think, in 2018. So it's pretty recent, maybe 2017.
Is it nationwide?
It was a nationwide survey of 1,300 adults who described themselves as environmentally aware. So that was kind of, but there was a similar survey that found similar results among sort of a general population. So we were actually sort of surprised by those results ourselves. So we do think it's really important because if we want to make forest products sort of the cornerstone of a new bioeconomy, it's really important that people be able to trust that and that they have a good sense that when they are getting a label or a declaration that they can really rely on what it says. So yeah, I think TNC is quite interested in figuring out ways that we can sort of increase transparency and trust in the market.
Brian, I think that I'm not very surprised at that gap because the way the question is kind of phrased, it's we talk about forestry. If I think about federal forestry, it's not manifestation. So what I'm thinking about forestry is not necessarily what you are thinking about forestry. The way you talk about working for, but then not everybody is thinking of forestry the same way. And I think that that's the difference in how we, the general population, understand forestry. We know that tuna harvesting is bad for environment, tilapia is not. And we just don't say fish harvesting is bad or fish harvesting is good. So what happens in wood products industry, we don't have the tuna and tilapia differentiation. I think we need to incorporate that in the general knowledge so that people know when you're talking about wood, you're just not talking about wood, you're talking about sustainably harvested wood or illegally harvested wood or endangered species. So I think that lack of understanding in the population, that's the problem.
Yeah, that's for sure. One of the other really interesting things that we saw in that survey, which we didn't conduct, we were just sort of curious to know what it looked like. I think 4 in 5 American adults think that deforestation is a problem in the United States and Canada. So that was pretty surprising to us. So I do think it is largely a matter of the general population not really knowing that actually forest cover is increasing and we're not running out of forest in North America anytime soon.
Do we see the same impact if, we're talking about here in Washington State where we have trees in abundance compared to, shipping this product all over the states or all over the country and stuff, whatever? Do we have the same, I'm guessing the impacts are a lot lower. Or in earlier seminar, they talked about how, European CLT is at a competitive price with here in the United States or whatever. Well, as a developer, you might just be looking at the cost or whatever, but as far as the environmental impact of it, if those CLTs are coming from Europe or whatever, are we seeing the same environmental gains, or are we seeing environmental gains at all?
Yeah, I mean, my sense is, I haven't really dug into this, so if someone wants to correct me, please feel free. My sense is that ocean transport does not add a lot of emissions as a percentage of the overall impact of material sourcing, but since we want to stimulate a forest economy with this, we would obviously like mass timber to be produced near where it's used. We just think that it makes sense to do that. But that's not where the market is right now, and that's fine. That's just not where the market is. So.
We have time for one more question.
Great.
You could thank Caitlin one more time.
Thank you.